It's so nice that today we can use truly universal, easily convertible units everyone has agreed on. Not mentioning the parts of the world where the imperial units are still in use, there is though one black sheep. And that is the unit of plane angle 1 degree. Degree is not SI unit but is officially recognized and can be used alongside the official SI unit, which is 1 radian. One complete rotation is 360 degrees. In radians, 6.283185 and so on. Now, I guess many of you are actually familiar with this number. But before I start straightforward hate against the pi and begin to list all the advantages of using tau, let me tell you a little story and get to the point of this video. I think it's obvious that working with a nice round number like 360 is more convenient than using a random decimal. But stop for a moment and think, what would be a perfect way to measure an angle? Surely, there could be a way even better than the degrees. What about this? Let's say that 0 would be 0 and 1 full circle 1. Makes sense to me. Then how much is a half of a circle? 1/2? Well, there is actually a notation in which we can work with these nice numbers. Just multiply it with the circle constant and it is the same as using the radians. So, where is the problem? Let's be real. Tau is not well known, thus people had to stick with 2π as the standard circle constant. In my opinion, there didn't have to be a big problem with that, just stick 2π after the quantity, the same way you put kilograms or meters. But this is the point where the 2 starts getting us into trouble. For some incomprehensible reason, people started to multiply the quantity with the 2, leaving us with some unintuitive number times π. You surely know this from when you have been studying trigonometry in school. There is no intuitive connection between the fraction and the circle when using radians this way. It is worth mentioning that your teacher at primary school had probably used cake division when you first learned about the fractions. Now there is the cake again and the intuition gone. Absolutely unnecessarily. I'm not directly advising the teachers to use tau, as I understand it could be too extravagant, but for Christ's sake, don't multiply pi by the 2. It is no surprise then that people stick with the degrees. As you can see, with radians, it is one big misunderstanding. They can make the understanding of angles easier, but because people can't work with constants, then make matters even worse. Let constants be constants and don't mix them with the actual quantity. The worst thing that can happen, and happens, is that you multiply the quantity even with the pi itself, which leaves you with a crazy decimal number. To be fair, there could be some advantages to degrees even when using the radians correctly, or rather intuitively. 360 is a highly composite number. That means it's got a lot of divisors, and thus when you divide an angle you often do not end up with a crazy decimal. The same cannot unfortunately be said about division of 1. Of course, you can stick with fractions, which makes matters easier. It has all to do with the decimal system, as the prime factors often are 2 and 5. So only and only if you divide one by number, whose prime factors are solely 2's and 5's, you end up with a number with finite decimal expansion. As you can see, thirds, and not only thirds, of an angle can be harsh. But with that we are getting somewhere else. It would be cool if we counted in base 12, as it would be cool if we used tau instead of pi. But moral of this story is that pi itself is not a problem, but the way people use it. I made my best to explain why degrees are still more popular than radians. Oh, what about the compromise? Let's use guns. Or no. By the way, the gradients were originally invented by the French as the metric unit for angles to replace degrees, but as with them, they lack the connection to circle constant. Okay, that's all for today. Thank you for your support, and if you wish, like or leave a comment.